This conference will now be recorded.
Am I audible? Okay, I'll use the same data members from the car class. I'll make this class also as car class. Let me make this as public class. I'll call use these data members. I'll point it out here. These are the functions of the car class. I'll just copy it. Whether when required, I will change it out based on that. I hope I'm audible because I'm not getting an answer. Hello?
Yes, Kaushik, you are audible.
So I've just copied the methods. I'll change it as the recording happens. Now, generally constructors, why would you use constructors out here? That constructors constructors takes the name of the class file. And the first of this one. And second, I'm getting this somewhere else. Let me check out the class. Invent the same thing. I'll put this CS file out here. Maybe. Let me put it there. I don't need this. I'll close this, and this session folder has to be a starter. Okay, so I'll just paste this C# file. If we look at this is called as constructor knowledge, this belongs to a different class, namespace rather. I'll make it to the same namespace. No problem. So this is the knowledge part. I'll just copy this knowledge part and I'll discuss further. So they are basically used to initialize objects. That's the first thing. Generally, we have seen that the initialization of the object happens like this. This is the mode of initialization of object. Based on the requirement of the project, you are initializing the object. That's what you're saying. This is the first object initialization, and then this will be your second instance, right? Second object initialization. This is for a high-end car. So, like this, for example, if you have 100 objects to be created based on the requirement, all those 100 objects has to be initialized, and initialization has to be done in this particular manner as defined out here. Okay. So, if 100 object has to be initialized like this in this particular manner, then it is cumbersome, time taking, and it takes tenacity as well as waste of time. So this initialization can be done directly by the constructors. That is why I said that constructors are basically used to initialize objects. It reduces time to code and reduces the complexity of the application. See how does it reduce time and reduce complexity. Constructor do not have any return type, only data type. No data type or return type is allowed. Constructors in C# can be static and non-static. If you go to Java, there is only non-static constructors. Static constructors are not present in Java. But in your C#, you have static constructors as well as non-static constructors. Now, return types you don't require, data types you don't require. But yes, they do have accesses. So private, public, default, protected, scripted. Default means it is internal actually. Protected internal. So this can be the uh, okay. So these are the access specifier not only which can be used for your constructors, but they are also used for functions. They can be used for functions because of methods. They can also be used for data members. Uh, Constructor do have arguments, but it is not compulsory. The constructor will always take the name of the class file. So whatever is the class name, for example, this is the class name, constructor will have the same. Okay. Now, two constructors cannot be created with another. So you cannot have a constructor inside another constructor. That's what it is. can't create a constructor inside the body of another constructor. So it says this is cannot be created within one model. And this sort of given cannot create a constructor inside the body of another constructor, and that's why constructors have hierarchical levels. They are given the same hierarchy. Constructors are independent of each other. You can create n number of constructors in a class file, but remember that if you want to create n number of constructors, you should implement the overloading concept. So two constructors can have the same name, but argument should be different. And the signature should be different. The signature should be different. And if signatures are same, at any point of time you cannot change the name of the constructor because the name of the constructor will be the name of the class. You only have the facility to change the signature. And it is said that two constructors can be same only if their names are same but the signatures are different. That is how it will be allowed. If the signatures are same, that is same type, same number of arguments, which will get better. We'll see all these details out. And the concept for constructors having same name but different argument is called as overloading. Overloading is also called as compile time polymorphism. It is also called as your static polymorphism. Overloading is also synonymous with static polymorphism in compile time. And this overloading concept can also be applied with functions. I'm not showing you the overloading concept with functions because that's part of the polymorphism. Okay, but I have to show you in constructor because I said that we can have n number of constructors. The only thing that we have to ensure that the constructor name cannot change. The name of the constructor is always the name of the class, but signature has to be different. So you can have n number of constructors with the fact that you should not change the name, because the name will always come from the class file, but the signature should be different. And this concept of having same name but with different signature is a concept that is allowed in your functions also, and that is why functions support overloading and constructor would support overloading. So what I'm going to show you is basically the non-static constructor. So here I can write down already copied it out here. Yeah, so I can just remove this. Okay, now where do you create constructors? That is the question. You create constructors after the data. Create a constructor after the data. Here is where you can create the constructor. And I will show you a non-static constructor right now. Because in C# both static and first of all, it takes the name of the class file. So you just copy the class file out here. Create public. The constructor, a non-static constructor will not have a return type, no data type. Just public and name of the class. Put a parenthesis and this is the body of the constructor. Okay. This is called a constructor with no argument. There is no argument being defined. Okay, I can just basically do a console dot write line. Just write down constructor. Right. Now, one thing that I've not given the knowledge section is that constructor basically is to initialize object. How? Actually, the body of the constructor. Initializes the object. So this is the body of the constructor. So this body will initialize the object. How? Now, the object needs to be created. Let's create the first object. Okay. Car C1 is equal to new car. Now, I told you this object will be initialized by the, I'll call this as by the constructor with no argument. Now, why would that happen? So that means this object will be auto-initialized by the body of this constructor which has no arguments. Now, this constructor has no arguments because arguments are defined out here. This object will be initialized by the constructor with no argument. That means if I run this, let's say I run this class file. Obviously, this code is inside the main method, so this code will be compiled. Immediately, you will see that the object, the first object will get initialized for the body of the constructor. And that's why I've written the object will be initialized by the constructor with no arguments. The constructor with no arguments. Let's run this control F5. You can see the body of the constructor initializing the object. No argument constructor. Yes, I have done some mistakes in terms of spelling. But you can understand that the body of this constructor is initializing this object. If I create the second object, I create the second object. Copy and I paste it out here. And before I paste it, I will give a differentiator. So this is the second object I'm creating, referenced by C2. And you will see this object will be also initialized as the constructor with no object. Let's run this control F5. You can see no argument constructor is popping up 2 times. Because I have created 2 objects, so both the objects are getting initialized with the same constructor body. What is the reason for that? Reason is very simple. There is no argument out here. And if you look at this object, the object doesn't have any argument values passed. The constructor will see that what is the argument type, and if the object has been passed with the same argument value. If the argument value matches with the argument type of the constructor, the argument value is defined in the object. The argument type will be matched with the constructor. And if If the argument value matches with the constructor's argument type, the body of the constructor will initialize this object and this object. So this object is not having any argument values, and this constructor doesn't have any argument type. So that is why the body of this constructor is initializing both these objects. This is the funda, nothing else. That means if I have objects which has to be initialized in the same manner, a single constructor can do that particular thing.
Okay, but that's how I'm going to.
Okay, now for example, I create the third object out here. Now, this is again, I'm repeating the fact that I'm creating a non-static constructor. Because non-static constructor will have the non-static keyword. There's no return type, there's no data type. It takes the name of the class file, access specifiers can be used. So I will go out here and create the third object. Now let's say I pass on value. The values that I pass on is let's say Honda, Civic, price, copy that. Okay. Now if you look at, I have passed on the argument values, but which constructor is present out here which matches with the argument values type? The type will be string, string, and integer. Which constructor is there? Nothing is there. Okay. Now I also told you that if you have the same constructor, this is the constructor with no argument. I can call this the first one, and I duplicate this, copy it and duplicate it out here. Second one. If you look at, there is a red underline. The red underline is coming because you can have constructor with the same name. Name will be always the class file name. You cannot change this name of the constructor. It is always the name. But I have said that a constructor can have the same name, and this name cannot be changed, but the arguments can be different. Right. Here is the argument different, or rather the signature should be different. Is the signature different out here? The signature is same. Had I basically created, let's say, if I make this as private constructor, still it will not suffice to the terms and conditions because it is not looking at the access specifier of the constructor. It is looking at you have changed, if you have retained the constructor, it has to be retained as car only because constructor name is always the name of the class file. But what about the signature part? Signature is nothing but a combination of argument type, number of arguments, and the sequence of arguments, or it can be basically the the it can be as far as constructors are concerned. Constructors entire should have different signatures. Here, as far as this particular proposition is concerned, signature of a constructor should be different. In non-static, the signature of non-static constructor. So what do you mean by this? Signature non-constructor means argument type, argument number of argument, sequence of argument. So is any one of them matches? Any one of them is different between these two constructors. Nothing is different. Both the signatures are same. Both the signatures are same. So if the signatures are same and the name is same, if you look at this, here the signatures are same. The second constructor has the same name and argument as the first one. So what is happening? Overloading is not achieved. So what is the overloading concept? Overloading concept says that I've given out here. It is called a static polymer compile time. It says that the constructor can have the same name, but signature should be different. So here the constructor have the same name. You cannot change the name anyways. The signatures are also same. That is why overloading is not achieved. If you hover your mouse, what it says, types are already defined. A member called seater with the same parameter. So that is why I will comment it. This is what's for your reference, so that you can understand it. I will comment it from here and do a block comment. So that is the reason that it is showing you a syntax error. When you want to see it, just remove these, see what is the syntax error. And this syntax error is coming because you have not achieved overloading. So I'll create the third constructor out here. So what you have to ensure that the constructor name cannot be changed. Okay. A constructor with argument service. The constructor name cannot be changed. Okay. The access specifier does not matter. You should not change the name of the constructor. What you should do is you should maintain this particular formula. The formula is that either the argument types are different, okay, or the number of arguments are different, or the argument sequence types are different. So what I will do is that I will create a string let's say PM string model and dot integer string M I can integer P. Okay. And what I can do is that I told you body of the constructor will initialize this. Now you can see the red underline has gone from here. The values are of string values and integer values. And these argument values are matching with the argument types of this. So that means the body of this constructor will initialize this off. How do I can just write down console.writeLine argument based constructor. So whatever you do out here, you will understand that the body of this constructor will initialize the third object. Let's run it out. You can see argument based constructor. That's the body part of the constructor which has argument types of string, and integer. which matches with the values being passed in the third object. So what is happening? The third object is getting initialized by the body of the constructor, and that is why you are getting an argument-based constructor as the result of the third object. But I should not get this result. This is just to show you what is happening. I'll comment it. I'll create the body properly. First thing is that uh, you can have the body of the constructor anything. Remember that you can create a function inside it. You can't create a function. You can call a function inside it. You can call a function inside it. Call a function. Value initialization for parameter variable. Parameter variable are there. These are the parameters that call a function. Value initialization for parameter variable or local variable. Local variable means what? Whatever is defined inside this particular body is a local variable. Or data member. Data member means global variable. That is what you can do. What else you can do? You can basically create objects inside the body for any class. You can create object of any class. Just to let you know. So whatever I'm showing you is not the end of the world. You can do any of these steps. So I'll have a tangible body right now. So what I can do is I can write down. Let me get the breakout from here. Save some time. I'll change it. I'll call this with the parameter variable. PM space M is priced at P. That means this is I'm using the parameter variable inside the body. You can just double click and it highlights this PM. You'll see that where it is referencing from. This is the first thing. So we all had already used all this. Where will the values come from? Values obviously will come from here. These values are going to go to these variables, parameter variables that they are passed out here. Give you a logic. Okay, and I think you have wheels also, headlights, right? I can basically put wheel also, right? Wheel can be also 4. Okay, so here what I will do is that I will create one more and, W. And what I can do is the value of it. So I'm maintaining strings in integer and 4. That 4 is going to go out here. And I can basically write down that, do the same console. PM, what is the value of PM? This PM value is Honda. So Honda, value of M is Honda Civic. Civic has has 4 wheels. Value of W is 4. Right. And next is I can call the functions. What are the functions? Start function. I can call the start function. There is no concept of static or non-static out there. This is a non-static constructor. The non-static constructor, as the word goes, it's like a non-static function where you can understand that a non-static function or a non-static method can call a static reference as well as a non-static reference. It's a non-static constructor. So inside the body, it can call the static reference as well as non-static reference. So these are the static reference. Start method. It is static. So I can just basically give with the class name, you can call start. And what I can do is that I can change this. Not want to to pass the value of M and H with model and with the W. I don't need that. I can just write down the model M based on the requirement doing it. Model start by setting. So I call the start method and model out here M. The same variable is present out here. Past. Where you are getting the value from? Civic. Civic will grow out here. String civic. That will be passed out here. Civic. So that civic is string. So this is also a string type. The value of M becomes civic. Civic start. Static stop. Here I can also basically call the same string M instead of complicated things. M stops by applying break. So this is string M. Okay. I can call the stop method dot stop. I have to pass on again M. Where is this value of M coming from? From here. Where is this string M getting value from? From here. So that means the value of this M is civic. And that is getting passed out to string M again civic. Civic stop here. ABS. This is ABS. Okay. Now ABS is non-static. How do I call this? What is we call this? It is always good to call non-static references with this keyword. Anyways, I have not used it when it has to be used actually speaking. So you can call ABS directly with simple spacebar. ABS. This is also string M. I will use this non-static function. It can be called directly. Past M. This M is nothing but which M? The parameter. Now what is going to happen? So let's say this third object is for a high-end car. So high-end car will have ABS. and navigation system. Okay, this will the argument values are matching with the argument types also. The body of this constructor will initialize the third object. You can see third object. Now let's understand one thing, how it is used. Let's say I have the fourth object, and the fourth object also is also an object of a high-end car. What will I do? Fourth object is also for a high-end car. T4. And this high-end car object again wants to use the same constructor. What will happen? That object should pass on value in the same sequence. Should be string, string, integer, integer. So what will happen? This I will change it to, for example, BMW. Model is X5. The same sequence I'm actually passing the value. Price is 90 lakhs, 4 wheels. So this object will be also initialized with the constructor with arguments. Which constructor? Second constructor. This constructor is initialized because the argument types are string, string, integer, integer, and the values that are passed to the fourth object are also string values, integer value. When I run this, you will see that how it saves. Am I initializing the object? Am I initializing the object? You need to understand that how this object has to be initialized. You want to initialize this for a high-end class, I will initialize with the same constructor body. So what I need to do, pass on the values inside the object in the same sequence as the argument type sequence defined out here. The same sequence maintained. Run this. You can see what happens. BMW X5. It's saving your code, saving your time. Okay, now let's say I have the fifth object. Now this fifth object is for the low-end car. Low-end car will not have anti-braking system and navigation system. So I have to create a new constructor, the fourth constructor. And if you look out here, why the red underline is coming? The red underline is coming again because of the fact that the number of parameters are 4, number of parameters are 4. Parameter types are string and integer. Parameter types are string and integer. Sequence is string, string, integer, integer. String, string, integer. So you can't change the name of the constructor, but the signatures are same. If the signatures are same, overloading is not achieved. That is why you see a red underline. So what is that? I can maintain the same number of arguments in both. I can maintain argument type as string and integer. And I can change the sequence. Changing the sequence will suffice to one particular thing. I'll change the sequence. For example, I have a sequence of integer, W, integer P, string EM, comma, string M. I'm maintaining the number of arguments same as this. The type is also same, but the third behavior is not same. The sequence is string, string, integer. That makes it as a different signature. You see the overloading is achieved, the rate underline. Okay. The same thing you have to do with function. If you want to achieve overloading in function, function name should not be changed. It will have a return type, it will have a static and non-static concept. But yes, it will not have the change in the name of the function. You just play around with either the number of argument type should be different, or the argument should be different, or the argument type should be different, or the sequence of the argument type should be different to achieve overloading in function. They have just changed that. One more trick that I will do is that the parameter variable name will be equal to data member name. Data member name. What do I mean by this? How is wheels defined? Yes. I will remove the value of wheels from it because I'm defining it in the object, right? Where will from there. What I want intend to say is that here it is wheel, right? Price is price model. Copy this. The wheel, this is virtual manufacturer, price. If you see the parameter variable name is equal to the global variable. That means there has to be a change out here. Okay. What is the change? This wheel has to come out here. This price has to come out here. This principal manufacturer has to come out. The model has to come out. Okay, and this is a constructor for, let's say, I want to use it for a low end car. The body of this constructor should utilize a low end of car object. I will have to remove this model. Now, if you look at something, I've said that the name of the parameter variable is equal to the data member name. Now, I want to pass the values are passed out here, right? This is right. And this is a low end car, so I will basically say give Maruti Alto 800. Price is different for fine. So these values will go out here, and these values will be used out here. The body of this constructor will initialize this object. There is no harm in that. Run this. But if you look at what I have done, I have created this separate constructor with the overloading effect so that it can be used for a low end file like this. Navigate negative is also coming Y. So, navigate through the ABS. What is this ABS and navigate? Okay, that is coming because what is the sequence I'm following? String, string, integer, integer. That is present in this constructor. This body is initializing. My mistake, right? I have to follow this particular part. Wheel, price, string, research manufacturer, string model. So what I need to do? Wheel, price, comma, research manufacturer, and what? I have to follow the sequence. Otherwise, what is going to happen? That is why it was actually getting initialized for the body of this constructor, which is for a high end. Now you run it. Now you see it doesn't have the body parts of the navigation system in it. Okay. This is how you manipulate your code in the real time scenario. Okay. Now the scope of this is a parameter variable. Now don't think that I am calling the data members. Even if the name is same, name of the even if the name of data member and parameter variable is same, the scope of parameter variable is limited to the body of the constructor. To the body of the constructor. What do I mean by this? You can understand it. The even if the name is equal to the data member name, but don't think it is actually I'm calling the data member. The data members will have accessors like public, private, internal, protected, internal, protected. But parameter variable or local variable will not have accessors. Please remember that. Okay. So even if the name of the data member and parameter variable is same, the scope of parameter variable, the scope of this variable is like a local variable. It is restricted within the method constructor body. Now, if I want to increase the scope, if I want to increase the scope, what will I do? I will pass the parameter variable value to global variable. Global variable is determined. How do I do that? So wheels, this value is defined down in the fifth object as code. I want to pass it to the global variable because I want to increase the scope. How it is increasing the scope? When I pass the parameter variable value of wheel to the global variable wheel, obviously what is going to happen? The global variable wheel is public. It not only can be used in this class, but it can be used in other classes also of the same namespace or of different namespace. That is how you increase the scope. So what will I do? I will directly pass this wheel. I'm calling this wheel. I want to pass the value of this parameter variable wheels to the global variable wheels. Okay, so that I can increase the scope. And what I do, I use an assignment operator. Now here, the compiler has got confused. It is saying that argument made to the same variable did you mean to assign something else. Now, since the name of the parameter variable is equal to the global variable, and your intention was to basically increase the scope of the wheel's value, whose value is 4, as defined in the fifth topic. So I want to increase the scope of this wheel to the global variable. That is why I assign the value of the parameter variable to the global variable. But the names are same. Compiler is not understand. But you can understand one particular thing is that global variable wheel is static. Static references can be called with the class name. Now your green underline is gone. That is, now you are passing on the parameter variable value 4 to the global variable, increasing the scope of it. Now this card dot wheels is what you can pass out. That means now the value of wheels is 4. So this wheel is public static integer type wheel. That value of 4 can be used outside of this class. Now, I want to pass the price, which is a parameter variable price, to the global variable price. Global variable price is this, and price is non-static. Passing it to the global variable price is non-static. But again, the compiler is confused. That's why you see a green underline. Why are you passing the parameter variable price to the parameter variable? Compiler wanted to understand. What you are trying to say is that I'm trying to pass on the value of this price, the global variable price, and the names are same. So what do you do? How do you differentiate that this is parameter variable price, this is global variable price? Now, if you look at this global variable price, this is non-static. So non-static can be called as this keyword. But this is a keyword when it's used for non-static references. When the non-static variable name or the non-static function name is equal to the parameter variable name. Now it is understanding this means I'm calling. Now if you understand, if I use this, it's a reserved word dot, you will see price problem. It is a global variable price. That means the parameter variable price is defined in the fifth object. That is getting passed out here to the this price, and this price is getting passed to the global variable price. So wherever I have used price, I can just use this keyword. Depicted, which is the price, which is the cost. This price is calculated. Similarly, principal manufacturer. I want to pass the value, whatever is the value, to the global variable principal manufacturer, and that is your non-static again. So what you do? Compiler will also again get confused. You are saying that you want to pass the parameter variable to the global variable. It is non-static, so I will use this. And wherever I have used principal manufacturer, I will use this. Similarly, this model will pass it to the global variable model. The compiler scholar will get confused. Model is also non-static. Differentiate the disk plot model, the global variable model, whose value is nothing but the value of the parameter variable. Wherever I have used model, here also you can use the start and stop. Now, what is the inference of passing it to the global variable? Simple out here. For example, I'll show you. In this navigation start, stop, static, what will I do? Global variable can be used anywhere. And if you understand it, card.wheel is a static, so I can directly use it out here. So the value has been passed now to the global variable. The static method can call static reference directly. And you can directly print out this actually the value of. For example, I will do console dot write line. Just pass on start dot wheel. Where will start dot wheel get value from? Value has been passed in the global variable for the parameter variable in this construction. So the start function is called, the fifth object is getting replaced by this body, and here the start function is called. So when the start function is called, not only it will print out the stop function. So sorry, the stop function is called here. So when you are calling this function, what is going to happen? This will be printed out, and this also will be printed out as 4. And you can check it out, the result of the fifth object. Just control F. Stop function, what it is going to be. The body part will be as defined. You can see 4. So that is the usage of the scope, increasing the scope. You are passing the parameter variable value to the global variable. How? This is the matter. Static references with the class name. Non-static references with the disk name. So once I have basically passed out price value to the global variable price. Okay, what's going to happen? I can use price in any of the methods. Right? I can just write down console.writeLine, and I can write down this dot price. And you can see this is basically a keyword which is talking about the problem. Why? Because this is out here on static method. I'm calling a non-static. That is where it is coming from. What I can do is, if I want to call price, I have to call it with the object. We create an object in this topic about class c1 dot new class. Object will be you can just call c1. That is the reason I pass the parameter variable to the global variable. I can use it anywhere as a vision. I can use it here, this, here, like this. I can use it here in this function also. In this function, the static method can be called ABS. ABS you can call like this. I will not get an object with a non-static. What I can do is I can directly call the price without the reference to the non-static. Directly call. Or if you want to wish that this is a global price, then you can use this. You can understand that this keyword is used where you have non-static functions. You can use this to call, maybe understand this is a global variable. And global non static variable is the class. You cannot use this with a static function. You have to create an object, call with the reference variable C1. That is the difference of calling. Now, ABS is used in for object number 3 and 4 because these are global, high end. You see the ABS function we call in these two objects. And you see the what function is called, the stop function is called in this object. The stop function will call in this object will show you these values. Actually, it is called in all these. What I'm trying to tell is that once you have passed the values to the global variable, okay, you can use it any of the functions. That is the inference. Third four object you can see. This is the fifth object you can see. The motive is just to show you that what happens if you pass the parameter variable value. You can use it anywhere as you wish. Now, fifth object. That the parameter variable has been passed to the fifth object is getting visualized by this constructor only. Where I passed this parameter variable only. One, two, three. Answer remains same. Answer will not change. Okay. The behavior of a constructor getting created. So you can see that if the object initialization is same, for example, the object initialization for second and third is same. It is called the same constructor body. Which constructor body? So if I have another object with the same kind of requirement, that is the sixth object, and the sixth object is also for a lowered car, then I can ensure that the sixth object also getting initialized by the same constructor is getting for the lowered car. What I have to just follow is a sequence. So let's say this is 2 lakh, 2 lakh 20. So this is your Tata Nano. So you will see that the parameter values are matching with the sequence of the parameter types in this constructor. The body of this constructor is going to initialize the system. It is reducing the number of codes for you. This is the system. Okay. So that's all for today. Next time we will have to see the static constructor. And then we move to the overriding concept and inheritance. Any questions? Any questions, guys? Thank you.